Hey everyone, and welcome. Today we are going inside a machine that recreates one of the most beautiful, most poetic processes in the entire universe, the birth of Stardust itself. Let's get right into it.
So, it all boils down to this one single question. It's a huge one, right? When you look out into that vast, empty, silent space, how does something solid, something you could actually touch, just appear out of nothing but gas?
Now, when we say dust, I want you to get the image of dust bunnies under your sofa right out of your head. This is cosmic dust. We're talking about the literal seeds of creation. These tiny particles are the raw material for everything: planets, stars, and yeah, even the very atoms that make up you and me.
So, how in the world do you even start to answer a question that big? Well, it turns out you build a star in a box. Let's take a look at the absolutely incredible tools scientists have engineered to do just that.
So here it is. Meet the Stardust Machine. And yeah, it is massive. We're talking 10 meters long, a huge piece of incredibly precise hardware. At its heart, it's an ultra-high vacuum chamber, and it's designed to do just one thing, but to do it perfectly: recreate the conditions in the outer layers of a dying star.
Let's talk about the temperature inside. We're looking at 1,000 to 1,500 degrees Celsius. Now, to you and me, that sounds insanely hot, right? But in the life of a star, this is actually the cool zone. It's that perfect sweet spot where hot gas can finally condense and begin its transformation into solid matter.
Okay, so how does this amazing transformation actually happen? We're going to follow a tiny cloud of atoms as it runs what you can only call a 5-chamber gauntlet. It's a journey that takes simple gas and forges it into complex, authentic stardust. All right, this journey has 5 critical steps. It kicks off with a pretty violent birth at the plasma source. Then, a sudden, shocking chill causes cooling and clustering. After that, the brand new particles get a serious speed boost during acceleration, get analyzed in flight, and then finally, they make their final landing. It all starts here, in the first chamber. Scientists pump in simple gases, things like carbon or silicon, and then they just blast them with microwaves. This process rips the atoms apart into this glowing, super-reactive soup called a plasma. This is the raw, energetic starting point for our stardust recipe. Next up, you take that super hot plasma and bam! You shoot it right into a cold, empty vacuum. The sudden temperature drop is like a cosmic ice bath. It startles the atoms, forcing them to cling together, to huddle up. And this is it. This is that magic moment of what's called nucleation, where gas officially starts becoming a solid, forming the very first tiny nanoparticles. So now that we have these little baby bust grains, they get pulled into something called a molecular beam. They're accelerated into a perfect straight line, flying down this pristine cosmic highway that perfectly simulates the vacuum of deep space. This is crucial because it keeps them from bumping into anything else. Now, this next part is where the real genius of this machine just shines. While these brand new dust particles are zipping by at hundreds of meters per second, lasers and other instruments actually interrogate them in midair. They can measure their exact size, their mass, their chemical makeup, all without ever touching them. It's a perfect real-time snapshot of creation. And finally, the last step, the journey's over. After traveling that whole 10-meter stretch, the particles make this incredibly soft landing on a special collection plate. And what you're left with is this beautiful, thin film of pure, custom-made stardust, ready to be studied under some of the most powerful microscopes on the planet. Okay, so you might be thinking, that's an awful lot of work for a tiny layer of dust? And you'd be right. But the reward for all this trouble? It's nothing less than figuring out the fundamental recipes of the cosmos itself. You see, this machine is solving some of the biggest mysteries out there. Our telescopes? They're great at seeing the before, the raw gas, and the after, the giant clouds of dust. But they can't see the messy, crucial steps in the middle. This machine, it is that missing link. It shows us, step by step, exactly how simple atoms build themselves up into the complex structures that eventually form entire worlds. And this is where things get really cool, because this machine basically partners up with giants like the James Webb Space Telescope. You see, the JWST is spotting all these mysterious chemical fingerprints in the light from faraway stars, but astronomers have no idea what materials are actually creating them. Well, the Stardust Machine acts like a cosmic Rosetta Stone. Scientists can create a specific type of dust in the lab, measure its exact fingerprint, and then match it to what the telescope sees billions of light years away. It's incredible. What they're doing is they're literally building a golden library of stardust. Think of it like a cheat sheet for the universe. It's a growing database of all these cosmic fingerprints that will let us instantly identify materials anywhere in the cosmos. I mean, this could speed up the search for the building blocks of life on other worlds by hundreds of years, because we'll finally know exactly what we're looking at. But okay, this is not just about looking at distant stars. The knowledge we're gaining here has some absolutely world-changing applications right here on Earth. By mastering how to build these nanoparticles atom by atom, we could design smart particles that deliver drugs directly to cancer cells. We could build super efficient catalysts for clean energy. We could even create pollution-free engines because we'd finally understand precisely how soot is formed. So let's look ahead for a second, because this research, it's taking us towards a truly spectacular future. This isn't just about understanding matter anymore. It's about learning how to control it.
There's this quote from the research team that just says it all perfectly. We are moving from users of matter to designers of matter. Think about that. For all of human history, we've had to find materials and make do with them. Now we're learning to create exactly what we need, right from scratch.
And that's really the ultimate potential here. This machine isn't just a simulator. It's like the ultimate instruction manual. It is teaching us the fundamental rules for how to build a solid world from just a handful of atoms, the same way the universe does it. Which really leaves us with one final, kind of awe-inspiring thought to chew on. If we can now truly build with the very same stuff that makes the stars, what in the world are we going to create next?